Hello everyone. Today I am excited to present my project titled ChatDB, Enhancing RDBMS Querying with Natural Language Processing using Large Language Models. This is an innovative approach to bridge the gap between human language and structured database queries. Here's the roadmap for today's presentation. We will start by understanding the problem statement, move through the challenges, technology stack, system architecture, key features, applications, overviewing the front end, back end, NLP, and database closely, and conclude with a demo and future enhancements. The key problem we are addressing is the gap between natural human language and structured database queries. Non-technical users like clients, sales managers, and HR professionals often struggle with SQL queries and depend heavily upon IT teams or data analysts, which simply delays the productivity and proper testing. Our objective is to enable users to query databases easily in plain English, reducing reliance on any technical expertise. The system is highly versatile with applications in business intelligence tools, automated customer support, research data querying, and more. It simplifies database interactions across various domains. Text to SQL systems face several challenges. First challenge is handling linguistic complexity and ambiguity of natural language. Natural language queries often include complex structures such as nested clauses, pronouns, or vague terms. Handling these complexities and ensuring that SQL query accurately captures the user intent is difficult. Secondly, these systems need a deep understanding of the entities present in the database schema, such as the tables, columns, relationships, and their respective constraints. In real world applications, database schemas are often complex and can vary greatly between domains, making schema matching extremely difficult. Also, it is not only natural language complexities that bring challenges to the system, but also complex SQL operations like nested subqueries or joins across multiple tables. Another important challenge is cross domain generalization. Text to SQL models are trained upon one specific domain, which may not generalize well to other domains due to differences in schema structures, terminologies, or query patterns, making it difficult for models to perform consistently across wide variety of domains. This project utilizes a tech stack combining modern front-end frameworks like Angular 18, a powerful Django backend, flexible databases, and cutting-edge machine learning technologies to create a scalable, intelligent, and user-friendly system capable of solving real-world text-to SQL challenges. Here's an overview of the system architecture. It integrates a user-friendly front-end with a powerful backend supported by advanced NLP models and scalable databases, ensuring seamless interaction between the components. In this architecture, we find two major blocks: schema linking and text to SQL conversion. The user, using the web interface, proposes a query in plain English text. For example, find total number of students in your university from a particular branch. Then, the large language model does a schema parsing by identifying the keywords from the natural language query, like students, IIT Jodhpur, and engineering science branch, which is then matched with the entities present in the database, like the table name, column fields, etc. After the entire schema linking process, the LLM generates an SQL query for the user's question, which is then used to fetch results from the database. Front-end overview. On the front end, we have used Angular 18 framework for robust and dynamic interfaces, efficient development, component reusability, scalability, and seamless integration with the modern web technologies. This image here shows our user interface built from scratch where users can enter their question in the input text field provided, and just on a click, ChatDB converts it into a SQL query and gives the correct results. The backend, powered by Django, offers scalability, ORM capabilities, and ML model integrations for natural language parsing. Let us now understand the evolution of natural language processing for text to SQL tasks. As we look back to the research works done in this area in the last decade, we observe a clear shift from rule based methods to machine learning driven methods, and finally towards large language models. This evolution has dramatically improved the accuracy, adaptability, and scalability of text to SQL systems, making it possible to solve complex database querying tasks using natural language and minimal user expertise. Our NLP capabilities rely on Google Gemini Pro, a cutting edge LLM. It excels in semantic understanding and is versatile for tasks like SQL parsing and text to SQL conversion. Later, we have also used prompt engineering techniques to further optimize its performance. We have utilized few shot learning, an advanced machine learning approach where a model can generalize or perform a task using only few examples or shots provided during the training or inference. This approach is particularly useful for our task where labeled data may be scarce or expensive to obtain. We have provided 2 to 3 natural language queries paired with their SQL outputs as prompt in the input to the large language model without any additional training. It adapts based on these examples to generate appropriate outputs. The benefit of this approach is that it reduces the need of large labeled datasets and also adapt quickly to any new domain or tasks. For the demo, we have used a sample data resembling student data records in real-world situation. So, let's see the system in action with some sample queries. It is capable of answering questions like how many students are in each year, what are the highest marks by the department, and many more, showcasing its adaptability to diverse queries. Let's quickly go through our code base. Firstly, let's run our Django backend server. So we'll firstly open our backend folder in an integrated terminal, then start off by activating our virtual environment. So vn scripts and activate. So now let's run our manage.py script. So python manage.py run server. So now our backend server is hosted on localhost on port 8000. So let's open it. One more thing, let's before opening our API URL, let us firstly check our endpoint. So our endpoint is API slash text to SQL. Let's open and see that on a browser. So on clicking on the backend URL, we get to this page, which is actually not our API page. So we'll go into API and then type in our endpoint, that is text to SQL, and let's run it. So we find this REST framework of ours, which accepts the GET request. Now let's serve our front-end framework as well. So let's open the front-end folder in the integrated terminal as well. And now type ng serve. So the project is built and hosted on localhost with its default port, that is 4200. Let's control and click to open the link. So let us query some sample questions and test it. So let us try writing how many students are there. The one thing to note is that it does not require proper English syntax as well. There's no need to write the punctuation marks and use proper capitalization, etc. So let's run and ask. So we see it gives the correct SQL query and gives the proper result. Let's try doing what is what is the maximum marks. Okay, so it will query. So it is querying in among all the students and it is giving the result. That's 95. Let's try doing it in section C. So yes, again it is the correct SQL query that it is finding the maximum marks of students where section is C and it is 85. Now let's try to find the highest marks by each department. So ask. So we find, see, this is the SQL query, marks of each, and it is grouping it by the department name. So computer science has 95, 85 by electrical, chemical has 81. Okay, now let's complex the situation. Mm, which student has scored highest marks in third year? Let's do it like third year and from section C. Let's try. It's taking some time to. Yeah, so now we see it is selecting the student entire thing, the entire record from which has the year 3 and section C, and it is ordering it by marks in descending order and limiting it to 1 to get the maximum record. Okay, so now which student has the highest? So which top 3 students has scored highest marks? Let's do this. So see, now it is limiting it to 3. So it is giving the results also. See, now it is selecting name and marks. So this is working out very well. Looking forward, we aim to fine-tune models for domain-specific schemas, improve cross-domain adaptability, integrate multi-model systems for richer inputs, and enhance security and scalability for enterprise-level deployment. Thank you all for your attention. I would be happy to take any questions or feedbacks on this project. Thank you.